tonight I'm making my second video on triangles in a coordinate plane. So we're drawing triangles in a coordinate plane, and that means we're drawing them on a graph. And we want to give each of the corners or vertices of the triangle a different coordinate, and that means a different x, comma, y point on the graph. We're going to look at the same a triangle as we did in our first video. We're going to look at the triangle where we have the vertices 1, 1, 5, 2, and 3, 5. And today, we're not going to look for perimeter like we did the first time. Today, we're going to look at the different sides and we're going to see what the slope of the three sides of the triangle are. Let's first look at the side of the triangle that starts at the point 1, 1 and ends at the point 5, 2. What we want to do is we want to find the slope of that segment of the triangle. So I've put those points in a table of values, and now we want to calculate the slope. Here is my table of values. I need to subtract, and then divide. So I get that my slope of that first segment of the triangle is 1/4. We could, of course, use this equation. We could use the equation m is equal to y2 minus y1 over x2 minus x1. And that means that we have 2 minus 1 over 5 minus 1. So, oops, there's my hand. 2 minus 1 over 5 minus 1, and that is 1/4. So the slope of the first segment of the triangle is 1/4. We want to find the slope of the second side. So we want to look at the slope of the segment of the triangle that goes from 1, 1 to 3, 5. You can see I've made my table of values. You can use your table of values to find the slope, or you can use the equation m is equal to y2 minus y1 over x2 minus x1. The slope of the second side is going to be y2 minus y1 minus x2 over x1, and then we divide those two sides, so we get 5 minus 1 is 4, 3 minus 1 is 2, so the second slope is 2. So the slope of the second side is going to be 2. Lastly, we want to find the slope of that third and final side of the triangle, the side that goes from 3, 5 to 5, 2. So we'll do that right now. We're going to use the formula for m to find this last slope. We're going to do y2 minus y1, so 2 minus 5 over 5 minus 3. And that gives me 2 minus 5 is minus 3. 5 minus 3 is 2. So here is one slope. Here is one slope. Here is one slope. So we've got 3 different sides, and all 3 slopes are different. The big idea for this video is learning how to find out if lines are perpendicular or not. And that's especially interesting in a triangle because if 2 of the sides are perpendicular, that means there's a 90 degrees and it's a right angle triangle. The big question is, how can I tell if 2 lines are perpendicular? If you want to know if lines are perpendicular, you are going to need to look at the slopes and calculate the slopes and compare the slopes of the line. And if the lines are perpendicular, then the slopes will be negative reciprocals. Let's say that again. When lines are perpendicular, the slopes of those lines are negative reciprocals. So our goal is to figure out, what does that mean, negative reciprocals? That's what we'll do right now. So for example, I have this little chart here, and I have my first line has slope 2/3. If you have a second line and it's perpendicular, first of all, it needs to go from positive to negative because it says negative. And reciprocal means you have to switch the fraction. So instead of 2/3, it becomes 3/2 and it's negative. Or if the slope of the first line is -4, and -4 means -4/1, If it's a negative reciprocal, it goes from being negative to positive, and instead of 4 over 1, it needs to be 1 over 4. On this graph, we see that we have two lines, and we can see that they are perpendicular. There's a 90 degrees angle between the blue and the red. I can tell this because I could use a protractor and see there's a 90 degree. I can also see that they are perpendicular because when I look at the slopes, the first slope, the slope for the red line is 3, or 3 over 1. If I were to take the negative reciprocal of that, the negative reciprocal of 3 over 1, it goes from positive to negative, so it becomes negative, and instead of 3 over 1, it's 1 over 3. So you can see that the slope of the blue line is negative 1 over 3, which is the negative reciprocal of 3 over 1. Here's another example. I have two lines, the red line and the blue line. The red line has slope 3 over 4. If the blue line is perpendicular, then the slope should be the negative reciprocal. So instead of positive, 3 over 4, it should be negative. And instead of 3 over 4, it should be 4 over 3. And when I look at the equation for the blue line, we see that it's negative 4 over 3, which means that the red line and the blue line are perpendicular. So let's go back to see our three slopes that we calculated in our triangle. We'll look at them and let's see if any of them are negative reciprocals of each other. So we can determine if there are any perpendicular lines. So here are my three slopes. One is negative 3 over 2. One is 1 over 4. And one is 2. Let's take the negative reciprocal of all three of these slopes and check to see if we get any perpendicular lines. Here the slope is negative 3 over 2. If I want to find the negative reciprocal of that, the negative would change to positive. And instead of being 3 over 2, it would be 2 over 3. That means if there was any line that was perpendicular to this line, it would have to have slope 2 over 3. Let's look at the other ones to see if there's any that are 2 over 3. This is not 2 over 3. And this is not 2 over 3. And that means nothing is perpendicular. There's no side perpendicular to this side. Let's look at the next one. The next one is positive 1 over 4. If I take the negative reciprocal, instead of being positive, it will be negative. Instead of being 1 over 4, it will be 4 over 1. If I wanted to find a line that was perpendicular to this one, it would have to have slope negative 4 over 1. But we see that this is 2, and this is negative 3 over 2. There are no sides with slope negative 4 over 1. So there's nothing perpendicular to this. Same thing over here. Here I have 2. 2 is really the same thing as 2 over 1. If I were to take the negative reciprocal of that, instead of positive, it would be negative. Instead of 2 over 1, it would be 1 over 2. That means if I wanted a side perpendicular to this, I would need to have another slope of minus 1/2. But I can see that that's not minus 1/2, and neither is this. That means that none of our sides are perpendicular to each other. And if none of our sides are perpendicular to each other, that means I've got a triangle like this where there are no right angles. That means this is not a triangle where there's a right angle, because if there was a right angle, this side and this side would have to be negative reciprocals of each other in order to make it a right angle. So this is the worksheet from previous class. What I want you to do is, we've already found the perimeter. What you now want to do is you want to find the slope of all three sides of the triangle, and you want to see if there are any perpendicular sides, because if there's a perpendicular side, that means it's a right angle triangle. If there are no perpendicular sides, that means there is no right angle in the triangle.